and website purposes, I call today Unit 8, Day 7.5, right? At some point in the history, it got added in there. Practice day before tomorrow's quiz. All right, so if you take a look, super hard to read here because it's small, but you guys have it on a piece of paper, hopefully. Region R, enclosed by the graph sub. That says y equals e to the negative x equals k, where k is positive to the right of the y-axis, and the coordinate axes. All right, so 1980, no graphing calculator. So let's consider this a no calculator portion, right? How many will you have on your actual AP? 4 non-calculator, 2 yes calculator of this type of a question. All right, and as we get closer towards the exam, you are thinking 15-ish minutes per part 2. So for the 2 non-calculator questions, for the 2 calculator questions, they'll give you a half hour. For the 4 non-calculator questions, you will get an hour. So it's 15 minutes, but give or take, right? You can use less on one and more on another as long as it's in that same section. All right, so take a look. Write an improper integral represents the limit of the area of that region. What are you definitely going to do first here? Before you write that integral, draw the picture, right? E to the negative x. That should be, right? Aren't we reflecting, negate x reflecting across the y-axis? E to the x. So there is my e to the negative x. Ignore everything else in there. Right? But I got that region right there. From 0 to k, right? This guy right here, that's the k, and it's moving to the right. All right, so improper integral. What's the height of the rectangle? It's e to the minus k, or sorry, e to the minus x. So aren't we summing up those rectangles from 0 to k as k moves to the right? So we're saying limit as k goes to infinity. Write an improper integral. So we wrote the improper integral. Find the value of the integral if it exists, right? Are they essentially asking you converge or diverge? And if it converges, what's it converge to? Okay. So review of improper integral. All right. So you take the antiderivative of e to the minus x. What's the antiderivative of e to the minus x? E to the minus x times the negative 1. There's that chain rule, right? You could do a u sub. You could, right? U equals negative x. So we've got, keep that limit as k goes to infinity of that negative e to the negative x. All right, evaluate, right? So I'm going to say I pulled out the minus, up to you. Plug in the k, e to the minus k, minus plug in the 0, e to the 0 is 1. All right, now we take the limit. My brain has to do what? 1 over e to the k. If you don't need to write that, that's fine. You don't have to. But now, limit as k goes to infinity, this guy goes to 0. Minus a minus 1 is 1. So strangely enough, this area here, as k goes to infinity, the area is exactly equal to 1. Exactly. I'm seeing some head shakes. And yes, that is mind-bending in my opinion, right? Not only does it converge, that's a whole mind-bending in itself, but it converges exactly to 1. Yeah.
Oh, so it's exactly to 1, not like approaching 1?
No, exactly to 1. The limit, because we went to infinity, right? We went there, all the way there. That's the hard part, right? Yeah, look at Lauren's face. Like, what? You guys, I keep refreshing your memory on this, but you guys know that 1/3 is equal to 0.3 repeating, right? Same concept.
Oh.
It's not approaching 1/3. It's actually equal to 1/3, even though that 0.3 goes on and on and on forever. So it's a concept you're okay with, but you don't realize you're okay with it.
Looking at it in kind of a different way, just like,
Exactly. Yeah. Yeah. Which wins the race here? Which wins the race? Do you go to infinity faster than you approach 0? No, this function approaches the x-axis faster than k goes to infinity. So improper integrals, yes, somewhat mind-bending, if you think too hard about it, right? All right, now what we got? Part B. Find the volume. Now notice, we're done with impropers because they're just saying in terms of k. Find the volume in terms of k of the solid rotated around the y-axis. So I took this region here, rotated it around the y-axis. I'm not sure what that looks like, right? That's a strange looking shape. All right, so now, what method for volume are we going to use? Do you want a perpendicular rectangle? Or do you want a horizontal rectangle as k is moving this way? Which do you want, horizontal or vertical? Horizontal worries me because k is not actual, right? K is going this way. So how long is the horizontal? Which would be disks. You're correct, right? But are we going to have some issues? Are we going to have k minus 0, right? So the height would be k here. But up top here, would it be function minus 0? And we'd have to do some switching here to dy in terms of y. Horizontal, perhaps doable. I just think because of the split, that vertical rectangle is going to be an easier integral to deal with. If we do vertical rectangle, nice review. What method we got here? Shells parallel to the axis of rotation. We got shells. All right, so nice review. Shells 2 pi RH, right? The radius of the shell. So I take the 2 pi out. I'm going from 0 to k. We don't have a limit because they didn't actually want us to find diverge or converge. They just wanted it in terms of k. All right, 2 pi r. The radius of this shell is just an x value, whether I drew the rectangle here or somewhere else off to the right. The radius is that independent x. The height is that e to the minus x. All right, so now that we've got the integral set up, nice review of chapter 8. That's what I told you is the tricky part for tomorrow's quiz. Improper integrals still hanging in there from chapter 8. So do you have to still refresh your chapter 8 integration methods? What method we got here? How are we going to integrate x e to the minus x? One word. Yeah, tabular what? What's the rest of that sentence? Integration by parts. Integration by parts. I don't know that I'd use tabular. It's a single integration by parts with an x. You could use tabular. I told you when I showed you tabular that you guys would get tabular happy and you'd use it for everything. It should work out. I just tend to do that because it's a single. If it was an x squared, definitely tabular. Right? U equals x, to u is dx. What's left? E to the minus x dx. Integrate. Don't forget that negative. There it is again, right? So we get what? I put the 2 pi out. X times minus e to the minus x minus dx times minus e to the minus x, right, as the integral. So notice the minus in parts times the minus of the v gives us a plus in between. And I'm going from 0 to k. All right, so now what have I got to do? Now, here's something with improper integrals. I tend to use back substitution when I'm doing the evaluate. So look, I've got this guy right here, and I know I've integrated, so I'm going from 0 to k. So I plugged in the k, e to the minus k. Now, plug in the 0. Minus, when you plug in the 0, 0 times 1 is 0, so I didn't write it down. So I evaluated this guy from 0 to k. Now, what's the integral here? Another negative e to the negative x. And see how I'm evaluating 0 to k. If you have to use a u sub with improper integrals, I would tend to not switch the limits, right? The lower bound and the upper bound. I would tend to do your u sub, right? Get your antiderivative, back substitute in terms of x, the original variable, and then do the limit. I just think it's safer, okay? So keep that in mind as you're looking back at improper integrals. All right, so now what have I got? This guy here, minus, notice parentheses, plug in the k, plug in the 0, and now I'm just cleaning it up. 2 pi, I've got this first term, minus k, e to the minus k, minus the e to the minus k, plus the 1. Anything there? All right, lastly, really good review, old calculus. Find the volume. Base is region R, there it is. Cross sections perpendicular to the x-axis, right? And notice in my drawing here, right, the slanted y-axis, perpendicular to the x-axis, and shape is what? Squares. So what's one square going to be? Base times height. What's the base? The function's height. The function's height. We like when it says squares, right? You've been seeing a lot of, that's the nice one. Triangles, not as nice. All right, so what is the setup? From 0 to k. There's that e to the minus x, which is the height. Square it. So that is really what? You can't really read that, but what is this? E to the minus 2x dx. Now, you know the integral of e to the minus 2x is e to the minus 2x. But then, we have this like u sub, right? I just do the u sub. U is minus 2x. Du is minus 2 dx. Divide by the negative 1/2. And here's my message again about improper integrals. See how I have crossed off those bounds? Right? They definitely should not be zeros and k's. 0 would be fine. You'd plug in a k and get a minus 2k at the top. But if it's an improper integral, which technically this isn't because we don't have a limit out there, they're asking in terms of k. But again, I would go through, right? What's the antiderivative of e to the u with that minus 1/2. Notice now, I'm back substituting, right? Instead of changing those limits. I just think it's safer when we're talking about improper integrals. Doesn't mean it won't work the other way. I just think this is safer. All right, so we get the minus 1/2 e to the minus 2x. Plug in the k. Minus, careful, plug in the 0, and you do get a 1. So don't forget that 0 at the bottom. And then you can, right, either distribute or not. E to the minus 2k, right, times negative 1/2. So 1 over e to the 2k times the negative 1/2. Minus a minus is plus. Could you have left it this way? Yeah. Either solution's okay. Yeah, Lauren?
Why is there a minus on the negative 1? Isn't the 1/2 already, the negative on the 1/2 already taken away?
So that's gone. Fundamental theorem, plug in the k minus plug in the 0. So that's where that's gone. Good? Anything left there, you guys? All right, so a little bit left over from yesterday, Unit 8, Day 7. All right, so today's plan. Take a look at this guy. Now, hopefully this is not the only practice you do, all right? I gave you that list yesterday What is going to be the hardest thing for you to actually get back and feel comfortable and 100% with is that improper integral stuff. So you got to go make sure you go back to your notes. All right, go back to the homework problem. Make sure you're taking a look at improper integral. All right, chapter 8 methods. All right, then you've got an Euler's method here. Notice it says using the chart. Checking with the program. You won't have the program tomorrow because it's no calculator. All right. And by the way, answer key posted online so you can check all of them. Now, look at part B. Solve the differential equation, right, with the same initial conditions. Paying attention, put a little asterisk next to 2B, and you'll see on the answer key what I'm talking about. Paying attention to absolute value. All right. Paying attention to absolute value. So when you have to say ln of absolute value, pay attention to that when you are talking about a differential equation solving for y equals. Okay? All right, then put a big old star next to number 3. Your brain is going to be so focused on 4 through 8, right? These guys here, we've done a ton of work. It's the orange sheet of paper, right? You're going to go through your list of what test is what and how do I think about them. Don't get confused, though. Read the directions carefully when it says limit of a sequence, right? What is the nth root of n? That's a sub n, and it wants to know what the nth term goes to. So this is essentially n to the 1/2, sorry, n to the 1 over n. Isn't that a y equals ln both sides? Bring it down in front. We've been doing a lot of that. But for limit of a sequence, you are not using converge, diverge by a particular test. You're just doing limit. Could there be a y equals ln in there? Yeah. Could there be a bunch of L'Hopital? Right? If you're doing limits, there could be a bunch of L'Hopital. So I'm just making sure your brain understands the difference between sequence and series. All right, the 1, 2, 3, 4, 5 of them down here. I tried to mix them up. Right? Come up with about one of each for you. In my mind, the integral test is not really represented well here. Technically, you could, number 5, do the integral test. I don't know why there's 2 asterisks on number 5. Don't let that scare you away or make you hesitant. I don't know what they're there for. I could just wipe them out. All right. I think so, because I'm seeing P. But to me, number 5 is just by definition P series. But could you use the integral test? Yeah. So don't forget about the integral test. Also, don't forget about the very first thing you want to look at. What's the very first thing you want to think about when you're looking to see if a series converges? Nth term, you got it. The limit as n goes to infinity, right? 9 times out of 10, the limit's going to go to 0, and what do we know? Nothing. But every year someone tries to tell me, oh, look, the limit goes to 0, therefore converge. If the limit does not go to 0, what if the limit of a sub n is equal to e? By inspection, what does the series do? Diverge. Right? Because if the limit doesn't go to 0, the limit goes to e, then you would be adding something closer and closer to e every time. Yeah, okay. Correct. You can just check that in your head. Make sure you're thinking like, look at this, way bottom heavy, right? Bottom heavy. But if in your head, when you check it, you're like, oh, that might not go to 0. That's when you could very easily say, take the limit of the nth term. Limit does not go to 0, therefore diverge. But let me tell you, that'll be the most frequently missed question if that shows up. People forget about that nth term. Okay. Other questions? All right. So the tricky part about this quiz is it does span, right, 2